When we encounter an integral involving the product of two different types of functions, standard substitution often fails. Integration by parts is a powerful technique derived from the product rule of differentiation, allowing us to break down complex products into manageable pieces. In calculus, we need a systematic way to handle functions that multiply together, like polynomials and logarithms. Without a clear strategy, these problems can become overwhelming. Today, we will learn the specific formula and the strategy to solve these efficiently. The integration by parts formula states that the integral of u with respect to v equals u times v minus the integral of v with respect to u. Our main challenge is deciding which part of our original function should be u and which should be dv. To choose a u correctly, we use the ILATE rule. This acronym ranks functions by priority. The type of function appearing highest on this list in your problem should be assigned as u, while the remaining part becomes dv. Understanding these categories is vital. Algebraic functions include powers of x and polynomials. Trigonometric functions include sine and cosine. By identifying these types, we ensure that the resulting integral v2 is simpler than the one we started with. The goal is to pick a u that becomes simpler when differentiated and a dv that is easy to integrate. If we choose correctly, the second integral in our formula will be much easier to solve than the first. Think of it as a trade-off. We differentiate the part that gets simpler, like a polynomial that reduces in degree, and we integrate the part that stays relatively the same, like an exponential or a basic trigonometric function. Let's apply this. In the integral of x times sine of x, x is algebraic and sine is trigonometric. Since a comes before t in ILATE, we set u equal to x and dv equal to sine of x dx. Now we perform the operations. Differentiating u gives us 2 equals dx. Integrating dv gives us v equals negative cosine of x. We now have all 4 components needed to fill in our integration by parts formula. We simplify the signs to get negative x cosine of x plus the integral of cosine. The integral of cosine is simply sine. We add our constant of integration, c, to complete the solution. This is our final answer. Sometimes the second function is hidden. For the integral of natural log of x, we can imagine it is multiplied by 1. Since L comes before a in ILATE, we set u as natural log of x and dv as 1 dx. Differentiating natural log gives 1 over x, integrating 1 gives x. When we multiply v and do in the next step, the x and 1 over x will cancel out beautifully, which is why this choice is so effective. Applying the formula, we get x times natural log of x minus the integral of 1. This simplifies to x natural log of x minus x plus c. This example shows how ILATE works even when a product isn't immediately obvious. What if we pick the wrong u? If we had picked sine as u and x as dv, our new integral would involve x squared, making the problem more complicated. Always follow ILATE to ensure the integral becomes simpler, not harder. To summarize, identify your function types, use the ILATE priority to choose u, calculate your derivatives and integrals, plug them into the formula, and solve the remaining simple integral. Consistency with this method will solve most product-based integrals. You now have a reliable system for integration by parts. Practice identifying the function types, and the ILATE rule will guide you to the correct solution every time. Keep practicing, and thanks for watching. Generated by Vision Solve AI.